ground our ethics? To what extent do our genes determine our beliefs? How does the Big Bang Theory relate to the creation account of the book of Genesis? How does our trip to the grocery store affect the Amazon rainforests? Or what do wave-particle duality and the concept of the Trinity have in common? The questions of science and faith are endless, and the Canadian Scientific and Christian Affiliation exists to explore those questions and to bring people together as we have come together tonight to look at one particular topic. I thank you for being here. My name is Sid Ikma. I am the Christian Reformed Campus Chaplain at the University of Ottawa, and it's my pleasure to welcome you to this inaugural event of the new Ottawa chapter of the Canadian Scientific and Christian Affiliation. And I'd also like to say a special welcome to some people who are watching by live stream. So if you think it's a full room, there's actually people online watching as well. And hopefully there'll be some questions coming from outside of the room at the end. After our event, we invite you to a time of fellowship. There will be some coffee and some iced tea and water and opportunities to browse some information. Our guest speaker is going to say a little bit more about the CSCA organization, so I won't say too much of that as we begin. A couple of housekeeping notes. For those of you who are in the back, feel free to move your chairs around to whatever configuration that works well to be able to see as much as possible. I'm not going to lie to you. When we started planning this about 3 months ago, I said, last week of summer, it's Tuesday night, 20 to 30 people. So we figured this venue would be fine, but clearly we underestimated how many people are interested in the topic of physics and Christianity and topics like this, and we're thrilled. We're thrilled. And one of the things that's going to be going is there's a sign-up sheet that will be passed around, and if you're interested in knowing when more of these types of events are going to be taking place in the coming year, please just put your name down and we'll keep you abreast of whatever other events and topics will be discussed. So I'm just going to send that one this way. If you don't have a pen, there's also a sign-up sheet on the back table where there's information about CSCA as well. Tonight we are, and one other housekeeping note, if you're looking for a bathroom, it's down the stairs and to your left. So if you're looking for a bathroom later, it's downstairs and to your left. Tonight we are pleased to welcome Dr. Arnold Sikkema, Professor of Physics at Trinity Western University and President of the Canadian Scientific and Christian Affiliation. He received his Bachelor of Science in Physics and Mathematics from the University of Waterloo, his PhD in Superconductivity and Magnetism from the University of British Columbia, and he's done postdoctoral research at the University of Florida. I had the pleasure of hearing Dr. Sikkema speak about 5 years ago at an event entitled Test Tubes and the Glory of God. And at that event, Dr. Sikkema spoke with great humility to a group of pastors and church leaders about his personal journey of how his faith and his scientific assumptions were challenged and how his understanding of God's universe has been expanded. And I greatly appreciated the way in which he spoke and the way in which he challenged us to think about the amazing world of God and the part that we get to play in it. I am pleased to hear him speak again here tonight in Ottawa. Please join me in welcoming Dr. Arnold Sikkema.
Well, thank you, Sid, for that generous introduction. Thank you all for coming this evening. I don't know if you can hear me in the back. Like, people out there in the lobby, are you able to hear me? Yeah. Okay, great. I'll try to keep the volume up and maybe a bit louder for some of you sitting right in the very front, but that's light. Yeah, it's warm in here. I think you have the air conditioning on, I understand. So I don't know if it's going to overpower 100 warm bodies, but we'll see. Yeah, thanks, Sid. Where did Sid go? He's right back there. Thanks for the introduction, and thanks to the others in the Ottawa area who've been involved in organizing this local chapter here for the Canadian Scientific and Christian Affiliation, and for organizing this particular event. I also, of course, would like to thank the Laurentian Leadership Center for hosting the event and for hosting me. I'll be staying here tonight, so you know where I'm sleeping tonight. And also, Sid is part of the Ottawa Christian Reformed Campus Chaplaincy, and they co-sponsored this event as well. So this is part of a national lecture tour as we begin growing more local chapters across Canada. We have now 8 and hopefully soon 10 local places in Canada where science and faith is being discussed. Science and Christian faith is being discussed at public events, 2 or 3 events per year typically for the next while. And this is funded largely through the Templeton World Charity Foundation. So I also acknowledge their contributions to this. Yesterday I was in Halifax, and tomorrow I'll be in Montreal, and then the semester begins for me. So I'm glad to sort of be able to squeeze in this little trip just before that. Let me say a few words about the CSCA. How many of you are students, undergraduate, graduate, high school students? And so to be a member of the Canadian Scientific and Christian Affiliation as a student is free. So I encourage you to sign up. And the easiest way to sign up would probably just go to the website, csca.ca, and find a button how to join. So you can be a member for free as a student for a long time. If you're not a student, but would like to support student memberships that are free, please sign up and become a member yourself. So the Canadian Scientific and Christian Affiliation is Canadian, an affiliation of people connected together on science and Christianity. And so scientists who are Christians, science students who are Christians, and people who are working in fields closely related to science, like the history of science or the philosophy of science or theology, where that might impact and connect in some ways to science. Teachers, pastors, they're all welcome as part of the Canadian Scientific and Christian Affiliation. And we're a fellowship of scientists and those interested in science who want to understand how science should best interact with Christianity. There you can find our Facebook page and our Twitter feed as well. Another opportunity for students is if you want to attend a conference on science and Christianity, you can apply for a scholarship to travel to and register and stay at a conference. The next major conference of the Canadian Scientific and Christian Affiliation is going to be held in the Colorado School of Mines in Denver, Colorado next July. So if you're a student and want to go to Colorado and hear some great speakers and have fellowship with other Christians who are in the sciences, go and apply for one of those scholarships. So there's some little postcards on the back table over there that you can pick up about the CSCA. I'll mention a little bit later about the journal as it comes up in the talk itself. But there's also a creative writing magazine called God and Nature that our organization is also involved with the American Scientific Affiliation in producing. So those are some words about the CSCA. The lecture tonight is quantum physics and Christianity. This was a topic that was chosen by the various local chapters. They wanted me to speak about this topic. There were a number of other topics that I could have spoken on, but they chose this topic, and I think partly because they sense that there's interest in quantum physics. It's a sort of a nice buzzword. It's 100 years old for those of us who are in the field, but for many of you, it's perhaps quite new. And also because it deals with topics that I think are relatively non-controversial. Often you think about science and Christianity, you think, oh, there's a big battle, the creation-evolution battle, and let's go ahead and talk about that. Well, that's not the topic for tonight. This is thinking about quantum physics from a Christian perspective. And what is quantum physics, and how does Christianity connect in some way to it? And so some of the major and general themes relating to how science and faith can interact will come up in this lecture, and they also are relevant to matters on what are called creation and evolution, for example. So this is the outline of the talk tonight. I'm going to do a brief quantum physics primer. I'll try to show you what quantum physics is. I'm not assuming anybody knows any quantum physics, but how many of you here would describe themselves as quantum physicists? All right, there's at least one quantum physicist to hold me accountable. Okay, all right. And so I'm going to do a couple of demos. In my home university, I would actually bring the Geiger counter and some radioactive samples, but that was hard to sneak past the security for the airplane over here. I was really planning ahead. I would have just contacted Carlson and borrowed some of their equipment, but that was a bit too tricky. Then I'm going to spend the rest of the talk on thinking about quantum physics, both theologically and philosophically. under these sort of themes: creation, covenants, and law, some general perspectives on thinking and connecting science and Christian faith, talking about indeterminism and Christian theology. Quantum field theory, the most sort of modern, one of the most modern developments within quantum physics, which came up in the 1950s and 60s, and how that connects in some interesting way to the Trinity through the ways that relationships are expressed. And then I'll end with some discussion about electrons and biology and agency. So I have an interest in biophysics, and so how does biology connect with physics? And one of the ways it connects is going to be shown here in terms of how the quantum world opens up possibilities for the biological world. So what is quantum physics? So I'm going to do two demonstrations. One is spectra, looking at two different kinds of spectra, and one looking at looking at nuclear decay. So when you shine light through a prism, and this is an experiment done by Newton, he's famous for that, and somehow on the screen it doesn't show up. There's a prism here. I think some of you can really see a slight tinge color there. So there's a prism, and you shine light through a little slit, narrow slit of white light, comes and hits the prism and spreads out. And you've all seen this, hopefully. If not, please go and look for a piece of broken glass or a bendable piece of glass and let some light shine through it, and there you are. So, so the white light divides into a continuous spectrum. And one of the elements of the quantum world is that not all things are like that. So an incandescent bulb will produce light that does spread out like that through the whole spectrum. But fluorescent light looks more like, gives us a spectrum that looks more like this. So if you have a hot gas or a gas which is electrified and send the light from that gas through a prism, there's an invisible prism again, you would get just individual colors of light, not a continuous spectrum over the whole range, but just individual bits. And so that's one of the hallmarks of the quantum world. Instead of continuous stuff, you get discrete pieces. So light at this wavelength, this color, and another one, and another one, and another one. And so in fact, we use the different kinds of spectra of stars to identify what the stars are composed of. What are the chemical elements in the gases of those stars? Each gas has its own signature, its own fingerprint, if you will. So this is an element of quantum physics. And so if you next time you come across a diffraction grating, hold it up to a fluorescent light, and you can see for yourself the quantum world. You can see for yourself that light from the fluorescent tube is quantized. And if I was doing this lecture back at home, I would give you all a piece of diffraction grating. But you'll have to come to Vancouver to see that. Some of you are from, who's from Vancouver? I think I saw, there we go, another person from Vancouver, more than one from Vancouver. So come and hear my lecture in November, and I'll give you a diffraction grating. Okay, so the other demonstration I want to give on quantum physics is nuclear decay. So hopefully you've all heard of nuclear radiation. Nuclei of atoms, some of them are unstable and undergo decay. And the decay happens by what proton turning into a neutron, or a neutron turning into a proton and emitting a particle, an unstable nucleus emitting an alpha particle, or two protons and two neutrons together, or another unstable nucleus giving off a gamma ray. So there's different types, alpha, beta, and gamma radiation that are being emitted. And so some unstable nucleus will undergo decay. And I've got 8 different samples shown here. This is a simulation of what happens when you start off with, say, 4 nuclei that are prone to decay, and this is at time 0. And there I've got 4 different samples, each with 4 nuclei in them. And I've got 4 other samples, each with, looks like about 400 nuclei in them. And up here it tells you what the time is. So the number that's going to appear here is going to be how many half-lives. So when this number becomes 1, we expect that half of the nuclei will have undergone decay, and the other half are still around. And then when it becomes 2, of the ones that stayed around, half of them will have undergone decay. So we'll see the decays happening, the simulations of those decays. So let's just watch what happens. So here's what happens as we let time run by. So you just, and it's going to cycle a few times. It goes up to 4 half-lives and it just repeats. So you can see that in any individual sample there's decay occurring, and then you can also notice some other interesting things. That is, not every sample is the same, right? So you start off identically, and you get different results. So the kinds of features, I'm going to highlight 4 features. One of those is the discontinuity. We have nuclei that will, like this one here, is going to decay, right? It was discontinuous. It was there, and then it decayed. It didn't sort of slowly fade out, but it was a discontinuous change. Similar in a sense to the continuous light, instead is discontinuous individual pieces. So that's one of the features. Another is the individuality. So this particular sample behaves differently than this sample, and behaves differently than that sample. Every sample is different. They start off identically, and you can't tell the difference between them. There is no difference between them. But then as time goes on, they develop different paths. And the development here is random. So you don't see that the top half decays and the bottom half later on decays, but it's just sort of scattered throughout. It's a bit hard to see over here because it's just 4, but when you have a large number, then the decays show up randomly. So that each pattern, each of these boxes looks about the same right about now, but they're all different from each other. They look sort of similar. So there's a pattern within the randomness, and those patterns within randomness are part of what are being studied with quantum physics. And there's also, as I kind of hinted at this, demonstration here of indeterminism. So indeterminism, I'm going to talk quite a bit more about that later, and that is that starting off the same does not mean you're going to end up the same. So we start with 4 identical samples, each one does something different, and there's no way of telling from a complete study of any sample what will happen over time. So those 4 features are shown in nuclear decay. These are all features of the quantum world. So when quantum physics was discovered in the early 20th century, which is now more than 100 years ago, there was a major shift, at least among physicists, in understanding the world. So we had certain understandings of the world which had to change as a result of our deepening understanding of the quantum world. So I've got a list here of a number of different features of the world as it was understood in the Newtonian era, pre-20th century, so before the 1900s, before 1900, and the shifts happened as a result of the development of quantum physics to give us changes in many cases. So we already saw thinking of things as existing on a continuum to thinking of recognizing there's quantization. That's a shift. So we thought that material was continuous. So a piece of wood is just wood all the way. There were theories of atoms, but with the quantum world, we in fact were able to discover that there are individual atoms. So that wood is a little wood molecule, and another wood molecule. Of course, there are no wood molecules or wood atoms, but those things are made of carbon and hydrogen and all of that, and carbon and hydrogen are made of, etc. So we have the world is not continuous, but there's little bits. We went from certainty to uncertainty. So Heisenberg's uncertainty principle says that we can't know both where something is and how fast it's moving at the same time. So some of you maybe have gotten pulled over for speeding once. I don't know if you don't have to admit it, but on the speeding ticket it says you were traveling at this speed at this location, right? You were going 79 kilometers per hour in a 50 zone, and you were at, where were you? You were on, what's the street here? Metcalf. You were on Metcalf doing 79 in a 50 zone, and you were at Metcalf and Somerset, right over there. And so what you should have done, you should have taken a ticket and gone to court and said, Heisenberg's uncertainty principle says you can't know both where I was and how fast I was going. And then you would get your case thrown out and you'd be fine. You'd be all set. Well, that turned out it probably wouldn't really work unless you really managed to trick the judge. Because in each case, the 79 means something like within a kilometer per hour of 79, and the intersection, well, that's kind of a largish area anyway. So in the quantum world, in Heisenberg's uncertainty principle, what we know is that the more we know about where something is, that is, if we're able to really, really super localize something, then we know very little about how fast it's moving. So there's an exchange there that we have to give up part of our knowledge if we want to obtain the other form of knowledge. And so we don't know, or we know that we can't know both where something is and how fast it's going with infinite precision. We went from a world where we thought there were things like stones and things like ripples. So objects were thought of as particles, or there were also these waves. And we realized in the quantum world that all waves have particle behavior, and all particles have wave behavior. So light is both a wave and a particle, and the electrons that are particles also have wave characteristics. So we thought of the world shifted from a dualism of particles versus waves to a duality of a wave character and a particle character. This picture up here actually shows the wave function of a single electron in a ring of 48 iron atoms on a copper surface. This is, people have told you maybe that we've never seen an individual atom. Well, we have. We've seen many, many individual atoms. We can even see an individual electron. So here is an individual electron. That's what it looks like. It's that wave sitting there. And here are the individual atoms, the 48 atoms sitting on that copper surface. And we've seen them just as well as we see anything else, as we see them mediated indirectly. Like you don't ever see a tree directly. You see the tree through the light that is being emitted by it, detected by your eyes, etc. And similarly, we see individual atoms. We went from a world of predictability to a world of probability. So some of you maybe took high school physics and you had to calculate where does the baseball go if it's hit at a speed of 80 kilometers per hour with an angle of 45 degrees. Then you all sat down and calculated that. Some of you passed that midterm and some of you didn't. And we could all predict where it would land if we did the calculation correctly. With the quantum world, we can't predict where individual events would occur. We already saw that. We were looking at at those boxes of nuclei. We can't predict which one will decay first. We can't predict similarly where a particle will land if we aim it at a screen. We can talk about probabilities. What's the probability that this particle will decay? What's the probability that the particle will hit this part of the screen, etc. We're going to talk more about determinism and indeterminism later. We also shifted from thinking that scientists are purely objective, simply watching the world happen, and we were sort of taking notes. And we realize now that even in the quantum world, humans are subjective participants in the quantum world. Our observations change the way the world behaves. So in fact, electrons are more like children than they are like stones. We know that children act differently when they're being watched. Well, so do electrons. If we watch carefully, then they actually behave differently for different reasons than children do. And we also learned that humans have a part to play in terms of making an event become actualized. So in some cases, we have situations where there is a probability of one event happening one way or another, different probability for the event happening another way. And the standard Copenhagen interpretation of quantum mechanics says that the state of the system before observation is that there's 50% chance of this and 50% chance of that. That is all that is known. That is the state of the system. And it's the act of human observation that forces it to become one or the other. And that's extremized by this little illustration over here with Schrodinger's cat, where you take it. And this, I don't know if there's any cat lovers in the audience. Any cat lovers? So just maybe you can just close your eyes for this little story. So you put a cat in a box, which is a sealed box, and you have a poison, a cyanide in a glass vial, in a sealed vial, and above that you have a hammer poised, and the hammer is on a string which is connected to a lever, which switches when the radioactivity triggers it. So when there's a sample that will undergo decay with a 50% chance in a certain time period, then the cat will die with a 50% probability, and it will live with a 50% probability. And the idea is that after the time period has elapsed, the state of the cat is 50% alive, 50% dead. And then it's the human opening the box that forces the cat to become dead or alive. Until then, it isn't either. That's an extreme interpretation of quantum mechanics. There's some people who think that, others recognize, as I do, that all it takes is a large object doing something that can't go back the other way. So a lever falling is many, 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 many particles doing something together, which already breaks the quantum nature of the original state. So Volkenmohr describes this as a macroscopic, irreversible registration of a quantum event. I think I'll skip the rest of these and then go and talk about determinism and indeterminism a bit. So at the end of the 19th century, there were people who figured that physics basically had the whole world figured out. That if we were just given the ability to know everything about where all the particles of the universe are and where how all the particles are related to one another and how they're all moving, then we'll be able to predict the future perfectly. Because the future of every particle is determined by what the particles are doing now. So the laws of physics would tell us how all the little particles would bump into each other and how they would move and develop into the future. And the understanding was that people were made of particles as well, and so those particles would bounce around. And so the future, maybe we can't calculate the future, but the future is already determined by the state of the universe now. So that's the idea of determinism. The future is fully determined by the current state of the universe. So nothing can change at all. So there's all kinds of philosophies that might express the same sort of thing, but this was a thinking from within physics that said that the future is determined by the present. And so indeterminism is simply the negation of that. The future is not fully determined by the current state of the universe. And in fact, only a few really strange interpretations of quantum physics say that the world still is deterministic. Most people, most physicists recognize, and most others who have thought about this recognize that quantum physics shows that determinism is scientifically untenable. So you can't still be a determinist and accept quantum physics. The lights are going indeterministically on and on. Now, there are different interpretations. I was at a conference a month ago where someone discussed 20 different interpretations of quantum physics. And 18 of them said that there's indeterminism, and 2 of them said there's determinism, and they're all over the map. But most of the actual working physicists are recognizing the reality of indeterminism. That is, the things that I showed in the slides earlier, those decays of nuclei, there's nothing about any nucleus that determines when it will undergo decay and when it will not. There's absolutely nothing about it. There's simply probabilities. There's not some secret hidden thing inside the nucleus that says like it's, okay, I've got 20 more seconds and then I'm going to decay. But there's always that same probability, and it just happens for no reason of the physical world. So how does this connect with Christian thinking? I think Christians probably didn't think the world was deterministic anyway. That is, Christians do think, that God determines the future. Not all Christians do, but many Christians do. But that is not the same thing as saying that the universe determines its own future. So knowing everything about the universe shouldn't tell us everything about the future of the universe. Maybe if we knew everything about God, then we could know everything about the future of the universe as well, because God plays a role, God interacts, God is involved in our lives. There are miracles, and God answers prayer, and God works in history and makes things different than they otherwise would be. Now, we're not talking here about the idea of predestination. That's a different topic that relates to salvation. We're here talking about the physical world's development over time. And so I think standard Christian thinking never was deterministic, but now also in a sense science has kind of vindicated that way of thinking, if you will. It's not proof, there's still interpretation involved, but it's kind of nice in some sense that the scientific world, at least in physics, has also seen that we do have choices, for example. So we aren't simply bouncing around because of the particles in our brains doing things, but we are actually actively, as humans, created in God's image, able to think and to make decisions. Those are real decisions, real actions, and real expressions of human will. And God expects us to be responsible, and if we simply were determined by the physical structure of our minds and the physical structure of the universe, doesn't make sense for God to expect us to be responsible. That doesn't solve the problem of God's sovereignty and human responsibility, where the 100% adds to the other 100% and still gives us 100%. But there is a connection there somehow between this understanding of indeterminism and standard Christian thinking. So I'm going to talk a little bit about 3 different philosophies of science. Maybe you know there's many different ways of thinking about science. I just got 3 illustrated here. There's the naive realist who thinks, when I look at the world, I see the world, that's the way it is, I fully understand it. There's the instrumentalist who says science doesn't tell us anything about the world as such, it simply gives us the coping skills to deal with the world and somehow to make sense of it and maybe build instruments. And then there's the critical realist who acknowledges that our theories about the world reflect reality, but not perfectly, and they need to be constantly revised. Maybe you saw from my tone that I'm more in favor of critical realism than I am of naive realism. I don't think a naive realist would describe themselves as a naive realist. But instrumentalists do describe themselves as instrumentalists. So what do they think about indeterminism? Well, the naive realist would say, well, the universe really is deterministic. We just don't know it's a human limitation. An instrumentalist might say, well, who cares about determinism? Science isn't about the real world anyway. It's only about how to cope with it. Probably there's some limitations in our experiments or our concepts that eventually will be able to do an even better job of coping with the reality. And the critical realist, like myself, would say there really is indeterminacy in nature. There is this is a reality. So our discovery of the quantum world having this indeterminacy is real. There really is indeterminism. There really are different paths that the future could go into. We're not locked into a future because of the present. Now I want to talk about some general approaches that I have thinking about science as a Christian. So I'm a scientist and I'm a Christian, and these things relate in some way. And one of the main ways that they relate is it gives being a Christian, acknowledging the truth of the Bible, gives me the understanding of why science works. So science, in a sense, describes the regularities that we experience in life. Science gives us explanations for why the world has, why certain regulations are found and how they're connected and so forth. But why are the regulations in the first place? Why are the regularities in the world in the first place? Why are there these patterns of regularity? Why is it the case that if I drop a rock, it always falls? Well, it doesn't always fall, because sometimes I actually hit it before it falls. But if I drop it without anything else happening, it will fall. That's a regularity that we can depend upon. And in science, we have to depend upon those regularities, and we also work on describing and explaining those regularities. But why they're there? Well, because God has made a covenant with creation. In Genesis 8, verse 22, after the flood, God makes a covenant with creation and says, as long as the earth endures, seed time and harvest, cold and heat, summer and winter, day and night will never cease. I guess we're experiencing the summer and the heat right now. I understand Ottawa has periods where it's not so hot, it's a bit colder. Right? I've never been to Ottawa in the winter, but one of these days I got to come back for skating on Rideau Canal. Why are these patterns of regularity found? Because God declares that they will be there, and that He will be faithful to that declaration, to that covenant. We read in Scripture, throughout Scripture, God being faithful to His people, but God is also faithful to His creation. God's faithfulness is shown by the fact that science even exists, by the fact that we're able to discover and count upon regularities and their patterns to continue. There are different ways to think about lawful reality. So in physics, we have laws of physics. Some of you maybe worked with things like F equals ma in the past, and the distant past, which you blocked out of your minds, maybe some of you. Some of us treasure those times of thinking about force and mass and acceleration. Well, F equals ma is a law of physics. It's a mathematical law, right? There's mathematical work that has to be done in calculating it. It describes the world. He doesn't make the world be that way, right? So on the right-hand side, I've got God's laws for physical reality. I've already said that God's laws are covenantal, and God also prescribes the way the world ought to be. We only describe the way the world is. We don't, by writing F equals ma, make a mass accelerate because of a force, right? But God is the one who makes the world behave in the ways that He's declared it to behave. God didn't one day say F equals ma either, because that turns out is not quite correct. F equals ma was human formulated. Newton was a human being, right? And and his laws were subject to revision. And so we have better understandings of the world than F equals ma. So if you didn't like F equals ma in high school, that's okay, because we've gone beyond that in physics anyway, although we still use it every day for making ordinary things and pretending people to the moon, etc. We don't send people to the moon anymore, though, so I don't know. So the laws of physics are subject to revision. Some of God's ways that he governs reality are known by us and partially revealed, like patterns of regularity. God said there will be cold and heat, and summer and winter, and that sort of thing. It won't be summer, 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 and it won't be winter, 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 and never Christmas, right? There will be these patterns of regularity that go on. The laws of physics, I think we're getting better at them, and they seem to apply everywhere, but yet they're limited in scope. They don't cover everything. There's many things that aren't understood by the laws of physics. And the way that the fact that God governs the physical reality in these sorts of ways shows something about God. It shows us that God is faithful to his covenant. He's all-powerful, all-knowing, wise, loving, etc. So when I think about laws of physics, I try to teach my students that the laws of physics that we discover and that we talk about in the course are not the same thing as the way that God actually governs the world. God doesn't govern the world by the laws that we are studying. We are studying the world and understanding its character, and the world is behaving according to God's regulations. Other aspects of my thinking in general about being a Christian in the sciences is the importance of not just a sort of a theistic idea, that is, there's some kind of a God who's kind of somehow in charge, but there's the God of the Bible. There's the God the Father, the Son, and the Holy Spirit. And so there's a special task for God the Son, Jesus Christ. In Colossians 1:17, Jesus Christ is before all things, and in him all things hold together. So why is it that all things hold together? Well, because Jesus Christ holds them together. Hebrews 1:3, Jesus Christ is the radiance of God's glory and the exact representation of his nature, and upholds all things by the word of his power. He upholds all things. So if Jesus Christ if he went on vacation and said, today I'm not going to uphold all things, poof, that'd be the end of the show, right? Things wouldn't hold together. It wouldn't sort of start flying apart, but just wouldn't even exist. But each sheer existence depends entirely on God's sustaining in and through Jesus Christ. Some of you are familiar with the Reformed Confession, the Heidelberg Catechism, in which it says in question answer 27, God's providence is his almighty and ever-present power, whereby, as with his hand, he upholds heaven and earth and all creatures. So, as with his hand, he upholds heaven and earth. So there's like an analogy, just like there's a hand holding things, right? We understand that to hold something from falling, you have to hold, your hand can uphold something. And so that's the sort of analogy being made there. There's a really interesting thing that happens in quantum physics that I just want to briefly talk about. It's an interesting echo of this upholding. So now, I guess perhaps you know that in the planetary system, in the solar system, you've got the planets going around the sun. In the case of atoms, you have electrons, which exist in orbital motion around the nucleus. And there was a great mystery that was around in the early 20th century. Why is it that an electron, which moves around the nucleus, doesn't just spiral inward? Why doesn't it just sort of spiral in and keep on giving off more and more energy, and eventually, poof, it's gone? Well, one reason is because God, with his hand, upholds even that electron, preventing that electron from falling into the nucleus. Some kind of a God who's not very good might have made a world where electrons would sort of fall in and always collapse into the atom, and that world would poof. It wouldn't last very long, and we wouldn't be here to talk about it. I wouldn't be able to praise the Creator. So we can praise God for the fact that he's upholding the universe as with his hand, upholding the electron from falling into the nuclei, and we can describe that through the principles of quantum physics. So I talked earlier about the uncertainty principle. You can't know where something is and how fast it's moving. Right? So this is Heisenberg's uncertainty principle, which deals with the position and momentum of the electron. Momentum deals with the speed. Position is the location. So people have said, well, surely God knows where the electron is and how fast it's moving. Like, we don't know, but God knows. God is omniscient, right? I had this list of God's character. God is omniscient, so God knows everything. Therefore, God knows where the electron is and how fast it's moving. And so that was the sort of question or the assumption. I mean, I guess it's an exclamation mark there, right? God knows. And so I read a book by Dick Staplow, who's a reformational physicist from the Netherlands, a book published now quite a few years ago, called Time and Again, the Mathematical and Philosophical Foundations of Physics. And he actually, and I agree with him, said the answer to that question is no. God does not know where the electron is and how fast it's moving. Now, before you think, I better toss Sigma out the window because he doesn't believe in God's omniscience, I just want to point out to you that you also don't think that God knows the color of the number 2. Right? Does God know the color of the number 2? I don't think so. Some of you maybe have synesthesia and you associate a color with a number, but that color is not the color of that number. And in a similar way, I would say, God doesn't know where the electron is and how fast it's moving because it doesn't have a where and a how fast. So we've got these relationships, these descriptions, and these are position and momentum are aspects of laws that we use to describe particles. So the electron doesn't have these things, but we describe them as if they do. And then we run into recognition that, oh, well, maybe they don't. Right? The electron is a different kind of thing than something which has position and momentum. It always has a range of both. And in fact, our best understanding of it is that it's exactly that. It has ranges of position and momentum. It doesn't have a single one. And so it's interesting. It's an example of what I would call reductionism, trying to force a human description onto something in the world. They're saying, okay, you electron, I know all about motion. So you electron better obey my law for motion. Well, who are you to tell the electron what to do? The electron is what the electron is, what God made it to be. And it wasn't made, apparently, to be something which has both location and momentum. So in other examples would be similar to that. That is, if you tell a living cell, all you have to do is simply obey the laws of physics. Well, that living cell doesn't care about you telling it that. It goes and obeys the laws of biology. It goes and divides and interacts with the environment, and it deals with, and it has functions and so forth, and those are not existent within the laws of physics. They're biological properties. So we always need to be watching out for reductions and trying to reduce the world into categories that we've sort of figured out we've conquered, and we should more or less let the world be what the world is, and understand it from a humble sort of perspective. So another person who's written about this sort of thing is John Polkinghorne, an Anglican priest who was working on the quark theory in the 50s and 60s. He writes this interesting section in his book called Science and the Trinity. The veiled reality of the quantum world must be encountered on its own terms and in accordance with its Heisenbergian uncertainty. There is no universal epistemology. It would be epistemically disastrous to try to insist on the Newtonian clarity that we can often attain in the macroscopic world of everyday phenomena. So he's saying the same thing as I just said in bigger words. So we recognize that the subatomic world has properties that we're not familiar with. But that's not a good reason to reject the actual nature of that microscopic world. We have to face that world on its own terms. Similar to recognizing anything in its own terms. If we're studying a tree, we want to interact with the tree as tree. We want to study God, we need to interact with God as God. We can't use physics to describe God. We can't use biology to describe, social structures. So there are different theological approaches to indeterminism. I'm going to draw sort of two sides of the screen. I'm not saying where I'm living on which side of the screen I'm drawing, but I'm drawing sort of what might be a sort of a left or a liberal perspective, and a right or a super conservative spectrum on the right. So the future is truly future even for God, say some Christians. And other Christians say, well, God created the universe with the future all laid out. It's already all there. God simply sees past, present, and future all at the same time. On the left, indeterminism is absolute. Even God doesn't know what will happen, and God is ultimately helpless. And on the right-hand side, the passage of time, even just thinking about time passing is a human limitation, and uncertainties that we experience are human limitations. Again, on the left-hand side, the underlying laws of nature, there are underlying laws of nature that make the world be the way the world is. Cause and effect rules the show, and chance is part of that collection of causes and effects. And on the far right, scientific law only just describes things, it doesn't explain anything. And there's not any real cause and effect. Things don't cause other things to happen. It's all just simply God causing things to happen. So I don't know if there are any students of theology here. There's one single word that fits nicely under this category, and one other single word that fits nicely here. And the words begin with I and T. Does anybody want to volunteer those words? Yes?
Immanent and transcendence.
Immanence and transcendence, all right. So the left-hand perspective says God is fully within the world. The right-hand perspective says God is fully separate from the world. God isn't involved in the day-to-day affairs of the world, he just sort of runs it from a distance. Here God is totally enthralled to the world. And the biblical reality, I think, is that God is both separate from the world and involved with the world. And so neither of these two ends of the spectrum are going to help us to deal with questions of indeterminism. So God is both transcendent and immanent. God created time, and he joins humanity in our experience of time. Just think, for example, of the incarnation. Jesus Christ, God, becomes human, lives and breathes, tabernacles among us. God truly interacts with us. He is a personal God. We are persons. We interact with God person to person. And that's not a fully reciprocal relationship, obviously, but it is still a personal interacting relationship. God rules the universe in some kind of a consistent manner. He's made a covenant with creation. It's not just some sort of a mechanism that just runs. God has built cause and effect into the rational structure of the world. There's a nice phrase that appears in Genesis 1 quite a few times, let there be. Let there be. What does that mean? It means that God allows something to have an existence, a sort of, under him, some kind of a relative autonomy. So let there be an electron means let the electron have a certain kind of character, and let it live and move and have its being in that character. Electrons don't live, but I guess that's biological things. Humans, what does it mean if God creates us as humans? So whatever character that humans have, God lets us have those characters. He doesn't make us little blocks and stones to move around. He doesn't make us into geared mechanisms, deterministic mechanisms, but he's given us indeterminism for us to work with because we are humans. Polkinghorne describes this as an open process. The processes in the universe are open to different futures and different realities, and there's a true becoming. The world is created by God, and it's becoming something different over time. The world is a changing world. It's a world of being and becoming. And I would say that God works with all things to bring about his purposes. Whatever happens, God is working in those things, and God works with those things to bring about his purposes. So that's a bit about indeterminism. Now I'm going to switch gears a bit and talk about quantum field theory. So ask the question, we've talked about electrons quite a lot. What is an electron after all? And so what is an electron? This is a picture. This is a sort of freehand drawing of mine of something relating to the electron. And this is called a Feynman diagram. This is Richard Feynman over here, one of the most famous physicists from the 20th century. He became famous in the general public when he explained why the Challenger blew up in 1986 by doing a physics demo as part of the press conference. He dropped a little rubber O-ring into a glass of cold water and showed that it became brittle. And that was why the Challenger blew up. So I guess one of the hallmarks of physicists is that we do demos in our press conferences. I did quote demos earlier on, right? So there's Richard Feynman, who's figured out a lot about the nature of the electron. So this diagram, it's a kind of complicated diagram. This is actually a calculation term, which is a bunch of integrals, and we can calculate the value of that. But what it's saying on a conceptual level is that okay, every straight line is an electron. So here's one of the things that an electron is and does. An electron comes along. So how does the electron get from here to here? This is the question. What's the propagator of the electron? So the electron comes along and says, okay, I'm going to go off and turn this way, and I'm going to give off a flash of light. Okay, so this is a photon, a particle of light. And the electron that turned off this way turns again and gives off another photon. And this photon says, you know, I'm going to emit an electron and an anti-electron. And then this electron emits a photon, and all of that stuff carries on. So you could write like a nice narrative of this. You could give this to a 6-year-old and have them, you know, tell the story of the electron in this particular diagram. Now, what's going on is that we're not saying that an electron comes along and does these things, but this is one of the things that the electron is doing as it is an electron. In fact, what the electron is all the possible things that it could be doing. So how does the electron get from here to here? Well, it does every possible thing that it could do and continues. So I'm not saying that it looks at all the possibilities and chooses one of them and does it, but it does all of them. The electron, this is called the sum over histories. So that to get the full result of what the electron is, we need to include all of the possible things that the electron could do, and then it actually does do all of those things. And if we miss any one of those terms, we get a mistake. So if we miss one little diagram in this calculation, we're going to be off. Now, interestingly enough, this part of the diagram could be replaced by this whole thing, right? So you can shrink this down, put it right there, and that'll be another thing that the electron could do. In that, there's another little line, which, same thing, right? So all the way down, infinities upon infinities, and the electron is doing all of those things. So the electron is not simply a little particle sitting around which has the ability to interact with other electrons, but it is the full set of all possible things that it could be doing. It's a deep and mysterious kind of topic. So the electron is the full set of relationships that it could possibly have. This is worth reflecting on for a while. So Prigogine and Singers say in their book Order of Chaos, for an interaction to be real, the nature of the related things must derive from these relations, while at the same time the relations must derive from the nature of the things. So there's sort of this cyclical reality to it. So what is an electron? Well, it's the interactions it has with everything else. What is everything else? Well, the interactions it has with everything else. And so it's like fractals in a sense. So one of the things that I think this impacts in our Christian understanding of the world is that we should not think of the world as being simply a bunch of stuff that God made, and then God declares how this stuff will then behave. So God doesn't first make electrons and then say, okay, electrons, now that you're electrons, now I want you to interact with photons. It doesn't work that way because the electron itself, sitting there by itself doing nothing at all, is in fact doing everything all the time. So the electron is the full set of relationships it has. So instead of there being sort of a three-structured thing of here's God and here's the things in the creation which God governs by some kind of a law, so this God law thing, instead of that it's just God and things which are lawful. So the God governs reality, and that reality consists of lawfully behaving things. James Clerk Maxwell, one of the top physicists in the 19th century, thought a lot about relationships and fields. He worked on the understanding of electric fields. Maxwell, this is what gives me an opportunity to introduce the journal. So there's a quarterly journal that the Canadian Scientific and Christian Affiliation, along with the American Scientific Affiliation, produces every 3 months. It's called Perspectives on Science and Christian Faith. You can see in 1989 it was in its 41st volume, so it's continued into now. This is an article by a historian of science, Jim Neidhart, who wrote about and studied Maxwell's writings, his personal reflections, and so forth. He realized the importance of Maxwell's understanding of Christian theology, Christian understanding of human persons, Christian understanding of the Trinitarian God in his development of field theory. So for Maxwell, says Neidhart, central to the biblical understanding of the person is the reality of human relationships as an integral part of what persons really are. You as a person are not an isolated individual, like a Newtonian particle separated from other autonomous particles, but are interrelated with others, your parents, your friends, even people with whom you disagree, maybe me. These interrelationships constitute the very stuff of personal being. This deep appreciation led to Maxwell's development of the electromagnetic field in order to describe particles as never separable from their interactions. And so we can't, so he's saying the same thing, not knowing about electrons, but he was talking about electromagnetic fields. Electrons weren't discovered until 1897. This is Maxwell writing in the 1850s or so. So he recognized this neat fact that to be human is to be a set of relationships. So humans are not just autonomous individuals. We're all deeply connected. And if you think about what it means to be you, you are not just like everybody else. You're unique, just like everybody else, right? You have your own set of unique relationships that absolutely nobody else has. So those relationships constitute who you are. They're not sort of peripheral. They're not some sort of a secondary thing that, oh, well, yeah, I'm a person, and oh, yeah, a couple other people maybe have some effect on me. But no, your personality, your personhood is intricately connected with your relationships. Similar in some echoing sense here with what electrons are doing as understood through quantum field theory. Colin Gunton, a great Reformed theologian from the mid to late 20th century, has a book called The Promise of Trinitarian Theology, and he talks a lot about modern field theory, like quantum field theory. He says that modern field theory has led to the conceptual echo of Trinitarian theology and relativity theory and its developments. The physics of relativity, which I unfortunately didn't talk about tonight, that's a different field, but it's similar in a sense to what the quantum world is showing. The physics of the quantum world also introduces a dynamism into the way things are conceived. There are no unchanging substances which enter into relations, like Aristotle and Newton thought, but the whole universe becomes conceivable as a dynamic structure of fields of force in mutually constitutive relations. The universe as a whole has an inherent directional dynamic. So the universe and the parts of the universe, the things that are interacting on a physical level, even that is an echo in some sense, says Gunton, to the Trinity. We recognize in Christian thinking that God the Father, Son, and Holy Spirit are involved in, even apart from the created reality, are involved in a deep and intricate collection of relationships between them. And part of what's going on, people have said about the creation, is that God spills over that set of relationships into relating to the world and invites us, humans, to participate in relationship with one another and with Him. And that will bring us toward shalom, toward proper human thriving, etc. So the last little bit of my talk, which I'm getting toward, relates to biophysics, so the connections between physics and biology. So what are the relations between the physical world and the biological world? What is it about electrons that allows them to be part of something which is living? So electrons, in a sense, are kind of open to the biotic. Electrons are not alive. Electrons can't think. They can't reproduce. But electrons are the important part, a very, very important part of atoms, and atoms are involved in molecules, and molecules are involved in biochemistry, which are involved in your cells. So there's something about the electrons. Their physical properties allow them to be parts of something bigger than themselves, which have properties that are beyond the physical. So biological properties are not physical properties, but there's something right about the physical properties that allows the biological properties to be there. And in Reformational philosophy, we call this anticipation. So there's something about the electrons that anticipates the capacity for the world to be a world of life. And so part of the wonder of all this is that God, the Creator, designed all this to work so beautifully together. So electrons have properties of indeterminism, not just for the fun, but so that there can be life. So this is partly understood a little bit by the fact that the scale of the electrons and of the molecules in which quantum phenomena occur is just right. So the scale is such that there's quantum effects, but also the scale is that contributes importantly to what's happening in the biochemistry of your cells. And so there's some mysterious sense in which the indeterminism of the quantum world opens up the biological world to be a truly biological world rather than simply a physical world, a world of indeterminism and a world of agency and so forth. I'm going to go to agency right now. So, and I believe this is almost my last slide. So you're sticking with it. You're not melting it. It's pretty warm in here. I'm probably warmer than any of you, although I'm not sitting right next to other people. So, human and divine agency. What does all this have to do with quantum physics and so forth? Well, when we act as humans, then all of the parts of us are acting and are moving about as well. And when I lift my hand, you know, there are atoms that are moving around. They're coming closer and further apart. I don't go around and say, okay, you atom go there, you atom go there, right? I just say, I'm gonna lift my hand, and it goes up. Like, I don't know how, it just does. And all the stuff is just right. So all of the, I mean, I guess it doesn't work for everybody, right? Some people wish they could raise their left hand, their hands are not able to do that, right? And that's, we recognize that as some kind of brokenness in reality. So when I lift my hand, I'm not simply operating as a mental agent down onto the physical, because I'm not a mental agent. I have mental properties, but my brain is also a biological organ, and it has physical processes happening inside it. The physical processes aren't determining the biological processes which determine the mental processes, and neither is it the other way around. But I, as a human, are deciding something, and that shows up in all elements and all levels, the mental, the physical, the biological parts of what's going on. And so, in some perhaps analogous sense, God acts in the world as well. God doesn't say something like, well, I want Joe to meet Sally, so I'm going to bump a couple of electrons around in his brain and make things happen. He just brings Joe and Sally together somehow, right? In some kind of a mysterious way. And you can't separate God's action. You can't separate things that happen in the world into, oh, this is what God did, and this is what nature did, and this is what humans did, right? If Joe met Sally, you could say God's involved, and you could say that Joe and Sally were involved as humans, and the processes in their bodies were involved as well. They needed to have legs, to walk to the same place and meet, right? So all of these different elements of reality are happening at the same time in some sort of a coherent way. There are people who say this, that it's either bottom up or top down, but I would say that it's just coherent. So I act. It's not my brain that acts. So I react quite strongly against people saying things like, well, my brain told me such and such. Your brain is not able to tell you anything. Your brain is a biological organ. You tell yourself certain things. You have a biological organ working as part of who you are, but you also have your background and your decisions and all of that, your relationships, they're also all equally part of you. So the way that God acts in the world, the way that we act in the world, those actions span all of the aspects, and I've talked here mostly only about the biological and physical aspects of the world. So for further reading on questions relating to quantum physics and Christianity, I would just sort of recommend these three sort of important sources. John Polkinghorne, we already mentioned, a book called Quantum Physics and Theology. Stephen Barr, a professor from the University of Delaware, Modern Physics and Ancient Faith. I'm using it as a textbook in one of my classes starting next week at Trinity Western. And Hans Halvorsen is a professor of philosophy of science philosophy of physics at Princeton, and he's written a really nice chapter called Plantinga on providence and physics, which contains some further reflections on the sorts of things that we talked about here tonight. So with that, I'm done my lecture, and I'm willing to entertain questions for as long as you're willing to ask them. Although we kind of promised that 9 o'clock will be the end of Q&A, and there are refreshments that will be available afterwards. I also just want to pass around a questionnaire. So part of what we are trying to do is understand, like, how is it that you came here? What do you think about these sorts of things? And would you be interested in other things? So we've already passed around, I don't know if it's made it all the way around, a sign-up sheet if you want to be informed of future events. Has it come around this whole part of the universe already? I'll just pass these around. If you want to fill them in during the Q&A, maybe I'll just give a stack to you, Andre, and you can go sort of that way. Just sort of pass them around. And here's another one. Just if you could fill those in. Now, to entice you to fill those in, there's a nice prize that's available for. We're going to do a draw during the refreshments, and they'll give a prize. Somebody will be randomly, indeterminately chosen to receive some kind of a prize. Okay, so with that, that's the end of my lecture, and I'll take questions. So over there, yes.
Thank you very much. I wanted to ask you about something right at the end of your talk, because right at the end I sort of lost the thread. You said right at the end that you thought we could account for, that there could be a nice coherence of human, natural, and divine purposes. And many philosophers agree with you, but I don't see why or what role quantum physics played any longer in that. In fact, it seemed as though that would be easier to understand on the Newtonian picture you were projecting.
Yeah. So just let me clarify. I don't know if you all heard the question. The question was something like, I was saying something about how we can have a coherent understanding of human and divine and natural actions, and that would be, it would have been easier to understand on a Newtonian worldview than on a quantum worldview, perhaps.
Or at least just as easy.
Or just as easy. Okay. So just to correct you on, well, just to clarify what I meant, I did not mean that we can understand all of those coherently. But what I mean is that actions that God would do or that we would do in the world, or that happen naturally, those are actions which occur coherently across the full range of the aspects of the created reality. So when a human does something, when I raise my hand, there's physical, biological, mental processes all happening in a coherent way. That is, it's not simply a mental process, not simply a biological process. The biological process doesn't run the physical process. The physical process doesn't run the biological process. But the whole thing happens in a way that sort of covers all the levels of explanation that we might have. That's what I mean. I don't mean to say that the human, divine, and natural actions cohere with each other. I just meant that each of these actions on their own is a coherent kind of action. Coherently across the levels of reality. So let me just ask, another way that this sort of levels of reality is described is by John Polkinghorne, who says something like, what's the correct answer to the question, why is the kettle boiling? And there's all kinds of, so one answer is, well, because the kettle contains water, which cannot be in the liquid form above 100 degrees Celsius, and therefore it's undergoing a phase transition from liquid to gas, which occurs at 100 degrees Celsius. The other explanation is because I wanted a cup of tea, right? So what's the reason for the water boiling? There's a physical reason, there's the social reason, there's a biological reason, there's all these other reasons, like, there's the economic reason. So all these different reasons are all coherently in play all at the same time. The question of interest sometimes is, what does physics say about the water boiling? What does sociology say about the water boiling? And the phenomenon occurs across the whole span, and it can be understood from different fields of inquiry. There was another question, approximately, yes?
So at the beginning you were talking about how things behave differently depending upon whether they're being observed or not.
Yes.
How would you know?
Yeah, so how do we know that things behave differently when they're being observed or when they're not being observed? So there's a famous two-slit experiment. So we send, so I mentioned that electrons also are waves. And so we can send a beam of electrons to a place where there's two little openings. And then we have a screen where the electrons land. And where the electrons land on that screen, we see a pattern which shows that the electrons are waves. So that the electrons show up here, not here, here, not here, here, not here, in a pattern which is only possible if those electrons are waves. And they're going through just one slit or the other, we would sort of think. And so then we ask the question, well, which slit is it going through? And if we watch which slit it goes through, and if we catch it on the way through, it fails to act like a wave anymore. Now, if we watch it, it only lands there or there. It only goes through the one slit or through the other slit because you watched it go through the slit. If you stand back and don't watch, then it shows wave character. If you look carefully, you'll see that it shows particle character. So this has been done many times in many experiments, and it's quite convincing. Now, I suppose we are assuming there's regularity. we're assuming that the world would have behaved differently the second time if we weren't watching. It should have behaved the same way the second time if we also didn't watch. Right? Now this world might be a really weird world where all kinds of weird things always happen, like when we watch the third time and the seventh time this happens and that happens, but we assuming that the world has patterns of regularity, we realize that whenever we don't watch, it shows itself as a wave. Whenever we do watch, it shows itself as a particle. And so the question that we ask upon our observation changes the behavior of the particles.
Arno?
Yeah. Yes.
We have a bunch
we've
of
got questions from the internet coming in.
internet questions, and the way this program works is that they also not only can they ask questions, they can vote on which questions they want to see. So the most popular question is around something called non-determined human agency.
Non-deterministic?
Non-determined human agency.
Okay.
So you're going to have to explain what that means, because I don't know. But the question is it best to say that quantum physics suggests that there's a space for non-determined human agency? Or do you think the stronger claim is warranted that quantum physics actually proves that this is the case?
Okay, so I don't know if you all heard the question, but the question has something to do with non-determined human agency.
Yes.
And the question is, does quantum physics reinforce the non-determinist behavior of human agency, or does it prove this? Well, that's an easy question from my point of view, because proof never occurs in science, ever. We never prove anything. All we can say is we have good evidence for something, and I would say that in this case, we don't really know the connections between the quantum world and human decisions. There may be some connection, there might not be some connection. If there is a connection between them, then somehow the indeterminacy of the quantum world would perhaps show up in the indeterminacy of the human agency world. But also, the quantum world may not be related to the indeterminacy of the human world. So in either case, in that case, it wouldn't even show this. It wouldn't even show, or even be related to the human undetermined human agency. So there's a possible relation. It's pretty vague and unclear at this point, I would say. There are people working on a field called quantum brain dynamics, where they're trying to understand the brain and develop a quantum field theory of the brain as well. Yes?
Is the math complicated for quantum physics compared to Newtonian? Newtonian was very simple, like F equals ma. Not very simple, but certainly described.
Yeah, so the question is quantum physics, is the math for quantum physics more difficult or more complicated than the math for Newtonian physics? And in most cases, I would probably say the answer is yes. You need to know a lot more math before you start to make any progress in the quantum calculations. You need to understand how to solve second-order differential equations, which is something that you usually only do after 2 years of undergraduate education, whereas you can work with F equals ma in grade 11. On another level, there are certain equations in quantum physics that are more simple. Equations that say energy is conserved because of time translation symmetry. We have some really interesting conservation principles that apply really well in the quantum world that are more complicated to work out in the classical world. But sometimes it's in the eye of the beholder. Like, if you're really well trained in math, then you can say, oh, that's a simple equation. Whereas if you didn't have the training, you wouldn't even know what the symbols even stood for. So there's a really nice equation in classical electromagnetism that says box J equals rho, just 4 symbols. And Maxwell would have killed for an equation like that because he had pages and pages for something much less than that. We also have these sort of pictures of Feynman, which is a way of representing equations, and anybody can be given the task of drawing all the possible ways that lines can meet up with waves. So there are various answers to that question. So the basic answer is it is more complicated to do the math. There's another question from the internet.
Oh, there's lots, right? So I just try to do, one and then the other back and forth. The next most popular question is you hinted about the relationship with biomolecules. Does the indeterminacy of the quantum world cause the unpredictability of when and where of mutation? And if so, does this in some way let God off the hook for the mutations that cause disorders?
Okay, so the question basically is the indeterminacy of the quantum world important in mutations, for example? And if so, does that let God off the hook of problems, for example, cancer, right? And so cancer is often a result of some kind of mutation. I received some kind of mutation by a single photon that hit my back when I was 14 years old, and I got melanoma. Does it let God off the hook? Well, God created the whole universe, and so I don't think you can ever let God off the hook. But there are all kinds of things in the world that happen that we don't have good reasons for why they are that way. I think one of the basic Christian comforts is that God is with us, regardless of whatever situation we find ourselves in. And I don't think it's a matter of blame, although there's a standard understanding by many that the problems in the world, especially problems relating to human issues with things, is a result of the fall into sin. So I believe that the fall into sin is a real historical event and has real consequences for how humans relate to the world and how the world relates to us. But it is true that individual mutations are caused by quantum events. So a single cosmic ray emitted by some individual atom in some star millions of light years away that happened millions of years ago has traveled through space and has then hits a molecule and changes the behavior of that molecule. And so as a result of that quantum event, I got cancer. And some of your friends died, right, of those individual single pieces. Yet, the Bible says that God knows and cares for every one of us, and God has His eye on every sparrow, right? And so there's a sense in which God is certainly involved on some deep level, and is not letting the universe just do its own thing per se. A question in the sort of very back there. Yes, you. Yes, Pastor Dan.
Hey, so I got a two-part question for you. Under the old modern kind of Newtonian worldview, they talked about at the beginning, where it was like we could plot every particle in the galaxy, we would know the future. There was the critique of Christian theism that we were inserting and injecting God into the gaps of our scientific knowledge. That as science could describe more and more and more and more of how the universe works, the assumption of that worldview of that age was, well, the need for the God hypothesis would be less and less and less. Quantum physics seems to have opened us into a new era, at least, in which, some of the things that you speak of, or that are spoken of quantum mechanics, seem to be almost, we can't even get our minds around them at all, and it seems like we will never. And I would guess that there might still be a critique of quantum physics to just find that gap open almost widely, and now with the knowledge that we don't think we ever will close it. So here would be my question. To a person who would say, well, you are just still injecting God into the gap that now we know never closed. Or we've also seen with the rise of kind of the popularization of quantum mechanics, there are New Age teachers who are capitalizing on the popularity of some of that has come out of quantum mechanics to inject their own worldview into that gap. So my question would be to either the atheist who's critiquing you for injecting Christian God into that gap, or to the New Age guru who is injecting his own worldview into that gap. Why the Christian God? Why do you believe the Christian God is behind the realities that we're not discovering?
Right, so that's kind of a long
question. Sorry.
Okay, that's kind of a long question. I probably won't repeat it, but maybe it'll become sort of clear what I'm trying to answer when I give what I hope will be some sort of an answer. So the God of the gaps idea basically is that what we if we don't understand something scientifically, well, we just say that God is involved in that. And the basic problem with that is that as science progresses, we do begin to understand things that we didn't previously understand, and so then God sort of occupies less and less space for explanation. The solution of the general God of the Gaps problem is that God is involved in the whole show. So God created this whole universe, and He sustains the whole universe. He's always active in everything. He's not only working in the parts that we don't understand, He's also graciously given us the opportunity to understand certain parts, even sometimes large parts, of what is going on in the world. And so the explanations that we offer scientifically are not meant to sort of sideline God, but they're meant, in a sense, to complement God. So one of the interesting ways of seeing this is thinking about a pie. There's a speaker I just saw who spoke about eating pie, and which part of the pie belongs to God, which part of the pie belongs to science. Well, it's not like that. It's more like a layer cake. But the bottom layer is God in every piece, and science explains some of the top layer. And maybe science will understand more and more of the top layer, but God is always there in the whole bottom layer the whole time. So anything that we understand, God is involved in that. Now, on the quantum world and how the God of the Gaps might apply there, I guess some people would say things like, well, I mentioned how the act of human observation caused the cat to become alive or dead, and that's called the collapse of the wave function. Some people would say that, well, we don't need the human observer to collapse the wave function. God collapses the wave function for us ahead of time, so that God decides what the reality of the cat or any other quantum world feature would be. I don't think that's a scientific claim, and scientifically we would just say we don't know what causes the wave function, how this transition from a wave function to an individual result occurs. I'm not satisfied scientifically by saying, well, this is where God then steps in. I would rather say that, as I've done, God sets up these patterns of regularity. He's faithful to them in His covenant to creation. Jesus Christ sustains all things, including the quantum world, including a world of probabilities where things are combinations of different things. Eastern mysticism has jumped on quantum physics to sort of emphasize and perhaps overemphasize the nature of the holistic character of the world, that things are interconnected. Now, in the quantum physics understanding, we know certain things interconnect with other certain things. Quantum physics does not give license to the Eastern mystic to say, yes, all things are connected with all other things in some sort of a consciousness field. So I think that's an illegitimate application of some sort of a popularization of quantum physics to make it sound like it endorses that religion. So I'm not sure if I really answered your question fully, but maybe I got somewhere.
Okay.
One more question from the internet, then another question or two from here. We still have 5 minutes until 9.
Yeah.
Very patient.
Okay. The last most popular question from the internet. You had a slide on electronics and biology, and you used the term supraphysical.
Yeah.
Could you explain this further, what you mean by that term, and is it a spiritual or non-physical aspect to it?
Okay, so yeah, this is the slide that was being referred to. So what did I mean? What did I mean by supraphysical? Like electrons are parts of a greater whole with supraphysical properties. So what I mean by that is properties that are sort of, in some sense, above the physical properties. So I sort of think of the world and our descriptions of it in some sort of a layer. The simplest descriptions of the world would involve space, and the next more complicated would involve number, and the next more complicated would involve interactions. We have the physics, and the next more complicated would involve generations, which is biology, and the next most complicated would be mental properties and so forth. And so in that sense, I just mean by supraphysical, that is things that are beyond the physical. Like a living cell is beyond physical. It is physical, but it's also more than physical. So that's all I mean by that. This last part of the question was something.
Well, is this spiritual or non-physical
spiritual
aspect
right.
to this?
So I would not say that's a spiritual. These are not spiritual properties. Of course, God, the Holy Spirit, is involved in the whole show as well, and so everything in a sense is spiritual. But I don't mean the spiritual in that other sense that it's non-physical and therefore spiritual in the way that some people might read the Apostle Paul and saying, you know, we have physical bodies and later on we'll have supernatural bodies. I don't think that's the kind of thing that definitely not the kind of thing that I'm talking about here. But there was another question from over here. Yes.
I was just going to ask, Newtonian physics leads us down a road of determinism and uncertainty. And Newtonian physics is really all that was required to send people to the moon and to do all the space missions and such. And we've been very successful with that. Quantum physics, on the other hand, dwells in the realm of uncertainty and indeterminism. Yet quantum physics is essential in the engineering and building of all computers and semiconductor devices, cell phones and such. How would you explain that we've been so successful in the engineering and construction of these devices, given that it's based on science, which has uncertainty and indeterminism sort of at its root?
Okay, yeah, so the question is basically, how is it that classical pre-quantum physics understanding has been so successful, like sending the man to the moon, even though we now know it's been, you know, that the world is understood better from a quantum perspective. And the basic answer is that the kinds of things that we're talking about, like rockets and, you know, tanks full of fuel and people and planets and these sorts of things, are large objects with many, many, many atoms and molecules. And I don't mean just many, many, but I mean many, 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 many. Right? So 10 to the power of 30, 10 to the power of 32 numbers of atoms. So when you have many, many atoms together, each one is unpredictable, but as a whole, they're very predictable. And so the sort of demo that I had up here, you know, it's very predictable after 2 half-lives how many there are. Even when there's 400, this is I think 400, and when there's 4 million, we can be even more precise. And the more there are, the more precise our calculations can be. Those individual probabilities turn into things that we can really precisely calculate. And people make money on this all the time. So casinos use the fact that even though the individual roll of a die is unpredictable, they know what's going to happen in the large scheme of things, and they're going to win, right? And actuarial science, people in life insurance, right? They don't know when any individual will die. From their perspective, it's random. You know, from the person's own perspective, it's because, you know, a particular disease they got or a car accident or whatever. But the insurance industry makes money because they have looked at these patterns of randomness and found those patterns. And so one of the things I would say reflects God's character too is that even though there is randomness on the individual level, that we can be thankful to God that there's this pattern of regularity that shows up on the larger scale. And that pattern of regularity on the larger scale is needed for larger scale systems not to depend so intricately on the individual tiny little variations. But yes, I also made a good point that quantum world is not irrelevant. I mean, many of our devices require quantum mechanics. The laser, for example, is a quantum mechanical device, and you know, lasers have had, you know, huge effects on all kinds of things. And I mean, I'm not going to even get started on what quantum physics has done for human society. Maybe one quick question, and then we'll have to call it. Okay. Yes, you. Sorry.
So.
If it's a quick question.
Yes, very quick. What I'm looking for is a summation or a resume of tonight's. So I want to understand what angle or what particular thing in quantum physics would have the greatest explanatory power to kind of give us an evidence of the existence of God or.
Yeah, sorry, there is no such thing. I would not say that quantum physics gives us evidence of God. I would not say that quantum physics gives us new apologetic arguments. My main talk is about the fact that quantum physics can be understood coherently together with Christian theology to understand the world as a whole. I'm not making a claim that there's no other way of understanding, but I find echoes of what we see in Scripture found in the realities of this world. Those echoes are not proofs, they're not demonstrations, and some people would maybe argue, maybe claim that, oh, because of there's randomness, there's no God, right? Well, I think I've tried to offer some good explanations how you can deal with randomness and still acknowledge the reality and covenant faithfulness of God. That's maybe a kernel, a quick answer to that. Now, I think we'll have to call that the evening. Thank you all very much for your attention. Let's Sid wants to stay.
Thank you, Dr. Fickman, for joining us here in Ottawa and for